Hi, this is Matt Lacey, Senior Product Manager at Daikin for the Single Multi-Zone Systems. Today I wanted to talk to you about infrared controllers and some of the options that are out there in the market. So I use the term IR blaster to really refer to these IR devices. Basically, an IR blaster just sends a infrared signal out. It blasts it out with really no regard to whether it's been received or not by another device. So some facts about infrared is obviously it uses light, so it can't penetrate walls or doors or any kind of solid object. Light also diffuses in space, so the further you are from the device in which you're trying to control, the less likely you are to be able to control it because the light may diffuse so much that it actually doesn't get to the device you're trying to control. So there's definitely a short range that this can be used for a primary means of communication. The other is that both the IR devices have to be able to see each other. It's what we call line of sight control. So you have to be able to see the indoor unit in order to control the indoor unit from the infrared device. So think of this a lot like your handheld controller that comes with your TV. Same idea. It just basically sends a command to the TV, and the TV responds, but then does not send a command back to the remote controller. So the problem with these, as I indicated, they're one-way communicating. Our indoor unit and other manufacturers' indoor units can receive infrared signals, but they don't have the ability to then transmit an infrared signal. So they receive commands, but they can't then send an acknowledgement of that command back to an IR device. So all the IR blasters that I'm going to be talking about here at the bottom use Wi-Fi and an app as the primary mode of communication with the consumer. So basically the consumer will make an adjustment on their app or their smart device, and that will then communicate through a cloud to the IR blaster. The IR blaster will then send that signal to the indoor unit. So this sounds cool. It sounds as if this is a full integrated type system, but there are some things to be concerned about. One of them is that there is a possibility to where the IR blaster and the indoor unit could be in the same room but have different readings of what the room temperature is. So hypothetically, if you have the indoor unit, which is near some TVs, or an old DVD player, an old stereo, something that's generating a lot of heat, and the heat obviously rises, the indoor unit could read an indoor temperature of 80 degrees or something even hotter potentially. If the IR blaster is on another part of the room and it says send a set temperature of 72, but it reads an indoor temperature of 68, the indoor unit might actually continue to run much longer than what the consumer may want it to run. So there is that potential that the IR blaster and the indoor unit could read different temperatures simply because they're using their own temperature sensor. They're not sharing that room temperature sensor. Another issue is that since the IR signal is one-way communicating, you can't tell from the app or your smart device whether or not the system has tripped on some type of an error. So like in the South, where cooling is primarily used, condensate overflow trips happen every once in a while when the condensate pan gets plugged up. The system will actually shut off. So if you're away from your home and you're using this as your primary source for cooling, you may come back to a home that's now nice and warm because the system tripped off on a condensate and you had no way of knowing that. You couldn't call a service tech or run home yourself just to fix it if you're a savvy person. So that one-way communication is limited in some areas where it might actually be important. Another issue is that the IR signal sends a command through the blaster, but then anybody else could come along and send a different command through the infrared controller. So hypothetically, if the consumer sends a command through their app of 72 degrees, the app will communicate through the cloud to the IR blaster, and the IR blaster will then send that 72 degree set point to the indoor unit. Anybody else could come along with the infrared controller and change the set point to something like 68 degrees. So that's especially important in areas of the United States where there are rebates being written around these smart IR blasters. For example, if there's an incentive to heat your system with a set point of no more than, let's say, 72 degrees in the north, which means you couldn't have a set point higher than 72. If you maintain a 72 degree set point or lower in heating mode, you would get some rebate back at the end of the month, or your bill would be subsidized by a certain amount. So a consumer could hypothetically cheat the system by taking the app, putting it to 72 degrees in heating mode. That set temperature is what would be communicated back to the utility, but they could then take the infrared controller and change the set temperature to something like 80 degrees, which is obviously a less energy efficient set point. So the utility company would be writing incentives and paying people out on saving electricity when in fact they really weren't. So it's there's an opportunity there to kind of cheat the system. But in all reality, they may be doing that on accident too, and not even knowing it's happening and actually doing it on purpose. So anyways, I just want to talk about IR controllers and IR blasters and what's out there in the market. I thought it was important to at least shed some light on what their capabilities are and what their capabilities are not. Anyways, that wraps it for me. So thanks for listening. I appreciate it.